So, good morning, everyone. I'm Takayuki Kanda from Kyoto University and also from ATR. Today, I'm going to talk about our relevant research about social robots in public space. And to introduce you what kind of robot we are studying, let me start with this video. It's a information giving robot in a shopping mall.
ATC の道案内やおすすめ情報を話せますよ。行きたい場所に合わせておすすめするね。どこに行くんですか？
どこに行くんですか？自動販売機。自動販売機。何これ？
自動販売機だね。自動販売機はここから
どこに行くんですか？
あっちへまっすぐ進んでその先のエスカレーターのところを降りて、
じゃあそこにあんねん。
その先のところにあるよ。
あるよ。ある。ありがとう。ありがとう。
どういたしまして。
楽しいこれ。
Well, this is the kind of the robot we are studying. And yeah, people are so happy about seeing such robot. This is our research aim. So yeah, in the future, we believe that robot will be ubiquitous everywhere in our daily life. And particularly, we initially focus on this kind of semi-public space. There, I believe that robot will serve such role like physical service, like carrying or bringing objects to people, or information providing and presence. By just having a robot, we feel the environment safe and enjoyable. Yeah, now people already start to believe that there will be many human work to be replaced by robots and AI, and this kind of service can be one of such future service. Let me briefly go through what kind of things we are developing from technical side. Yeah, I mean, detecting people in shopping mall is not that trivial things. It's difficult, complicated. So we basically develop sensor network to cover the environment. We put many depth sensors on the ceiling to cover wide, big space in the shopping mall. So this is one of the situation in which system track people from the entrance of the mall going through shops, big hallway, and exit from another place. Yeah, we develop such robust infrastructure to detect people, and we continuously found the needs of developing technique for human-robot interaction. What is it? Let me show one example. In this case, we developed a robot that distribute flyers. In Japan, this is very common service in shopping mall or public place. We thought it's that's an easy task because part-time workers can serve for such role. So we develop a robot that move toward a person and then give some flyer. But it was not that easy, which we found. People didn't take the flyer, and sometimes robot made people feel scary. Sometimes people say, oh, I don't need it. We learned from human behavior, but people do this. And we found that some people are good at doing this, some people are bad at doing this. Left side is the example is a good givers. She is so successful in 77% of the case. People took her flyer. The important essence of her behavior is that she keep moving around and approach to the target from frontal side, then only extend her arm nearby the target person. Right side, it's unfortunately a case with poor giver in similar location, similar flyers, but she was not so successful. What is the difference? She waiting someone to take the flyer and even, move back her arm. So, we decided to take the essence of this successful giver and implement it into the robot. I don't explain the details, but finally we made it. So robot approach from frontal side and only extend its arm nearby. And I mean, it come to be much successful. Without this model, robot was only successful in, let's say, something like 33%, but I mean, with this, it come to be 73% of the success. It's one example, but I mean, we keep accumulating such, let's say, knowledge about human-robot interaction and developing robot, as I show you in the first slide. Yeah, basically, initially, our focus was the person who is using the robot, let's say, user of the robot. But not only the user, but also other people in the environment are influenced by the robot. We observe some situation in which people got problem with robot. Left side is the case with congestion. So I mean, yeah, when it provides some service like information giving, people nearby the robot is happy, nicely seeing the robot. But in reality, what they are doing is they disturb the corridor. So other people who just wanted to go through, they had difficulty. On the right side, it is the case with disturbing pedestrians. Robot has basic capability to avoid other people, but still people feel it's strange, confusing. So we observe that robots do not have enough common sense about pedestrians. And I mean, we decided to model people's, typical behavior, how they avoid each other. This briefly describes the model we developed. It's pedestrian model for this kind of level of congestion. So each pedestrian agent predict future situation with other pedestrian. It's very different from normal, pedestrian model. So this prediction-based pedestrian model better predict such, avoiding behavior in relatively low density situation. Right side is a video with recorded trajectory comparing with this modeled trajectory. And yeah, we also compared with other pedestrian model, and this better predict pedestrian behavior. And we implemented it into the robot. First case, I show you the video only with collision avoidance capability. So robot don't collide into people, and find the trajectory that avoid other pedestrians. And let me show you. So and in case the robot was with this pedestrian model, yeah, it predicts other pedestrian coming and yield its course from much early moment. Didn't cause such dangerous situation. So yeah, we developed such model, and also for congestion problem, we decided to model the real world. So this is a simulation. I show you the tracking infrastructure. With that, we were able to track a lot of people in the environment. This is a modeled situation. It's very fast forwarded, but in big this hallway space and corridors, people are moving through, and actually there is a robot in the middle of the hallway. We modeled how often people are crowded around the robot, and we reproduced the level of congestion nearby the robot in the simulation as well. Using this kind of simulation, now robot anticipate how much of trouble it causes in, let's say, this relatively narrow space, for example. So, this reproduce the situation in which robot is moving through this narrow corridor. And you can see the color of people. This is simulate the level of, let's say, uncomfortableness in the situation of congestion. So robot compute in which area it would invite such congestion and choose better location. So with this, without, such model, robot often get into this kind of narrow space because it found many people to serve. So naturally, it moved toward such location with many people. But with having this kind of, let's say, model of congestion, robot can find better location where it can still move around, but don't cause congestions. So we thought, yeah, fine. So by doing this, it can avoid congestion, so robot can probably serve better to visitors. But in reality, it was not the case. We call the problem we found as robot abuse. What is it? Let me show you. In this video, robot is trying to move around. And in case if its moving course is blocked, it asks, please make a space for me.
ロビーです。今はパトロール中なので前を開けてくださいね。
Children continue to block the route of the robot. In this case, they continued it for 19 minutes. And during the moment, robot need to make such request for 45 times. I understand that if it is only once, twice, yeah, maybe it's from people's curiosity. But doing this for 45 times, it's not the curiosity. They know robot is in a trouble, but still enjoying seeing such reactions. And sometimes their behavior can be even escalated. This is the case with offensive.
今はパトロール中なので前を開けてくださいね。
無理ですね。あなたはバカですから。
通りたいので開けてくだ
そ
さいね。
れしか言ってねえや。なあ、このおめえは勘違いだ。出てこい。おい、潰すねこのロボット。お前はな、アホです。お前な、なんで
前を通りたいので開け
静か
てくださ
にしろ
いね。
よ。静かにしろよ、おい。ごめん、おい、止まれ。
Sometimes their behavior came to be even abusive. They started to, let's say, kick and punch the robot.
重いよ。
やめて。
助けて。誰か助けて。前を通りたいので開けてくださいね。
うるさい。うるさい。
開けてくださいね。ありがとう。
Association, this is thank you. But robot was just simple, so it said that, and children seems to enjoy. Yeah, I don't think children aim to break the robot. They are still doing, let's say, rough play. And we also did some interview study and found that, they know robot don't like such situation, but still enjoy doing this. Maybe they hope to find something interesting, or because other people did it as well. We recently also did some observation study, using this video recorded data, and we found that this is more like escalation. So, children imitate other people's behavior and conduct a little bit more escalated behavior. Let me show.
進めないよ。
The one of the child with this blue arrow started bad behavior, then the child with red arrow also did.
進めないよ。
Another case. Yeah, one child kick, then another child kick more. This level of abuse, let's say, started from simple obstructing to physical and repeated abuse happen continuously because one imitated others and others tried more and more. We are still trying to find the way to avoid such situation and still working. And only the way we found so far is that robot escape from such situation when it anticipates it is likely to happen. We have many data about this abuse. So we made some statistical model and we found, when there are more children, this is much more likely to occur. But when their parents are nearby them, they stopped interaction rather soon. And we just put such information into the simulation. And in the simulation, robot tried many situations, like going there, and try to plan what is the best behavior for it. If you see this situation, having robot in the middle of the hallway, and if there is a child moving towards the robot, I think you can imagine, yeah, soon likely that this child start, or perhaps another child come and they start doing such abusive behavior. Same thing is computed in the simulation. So this is the same simulation, but with some model about abuse. So this number in the video shows the potential risk having such robot abuse. So yeah, now robot is computing. Likely 75% of the case abuse will happen. And in case if another child in the simulation approach to the robot, what happen? This come to be rapidly grow up. 12% is risky. Likewise, robot compute such future situation. Then in such situation, for example, robot decided to move toward upper right side, in which his parents was waiting for this child. Robot has a sensor network, so it keep tracking the location of this child and the parents. So robot was successful in the sense escaping from this abuse, potential abuse. Yeah, but still, we didn't find other good way to completely avoid robot abuse, like convincing a child not to do so. Yeah, recently we are trying to move beyond such situation, and we named our research effort as moral interaction. What is moral interaction? As I show you, often people welcome robots and happy about getting service from robot, but it's not always. Sometimes it got some problematic behavior like robot abuse. If we think about future situation, hoping that robot will serve for many roles, like robot shopkeeper, robot guardian, security guard, etc. Robot need to, of course, nicely serve, but also need to cope with such problematic situation. And in the case of human, let's say if there is human security guard, human shopkeepers, people morally behave in presence of such other human peer. So there is peer respect and peer pressure in case of human-human interaction. How about human-robot interaction? Are there such peer respect and peer pressure? Maybe not yet. So important research effort here is to think about the way to make a robot peer that would serve for moral interaction capabilities like a human peer so that it can get enough peer respect and also peer pressure. This is still ongoing, but let me show one example of study. In this specific study I'm going to talk, we studied the way to admonish people. It's what human security guard would do for other human visitors. But we found that this is not easy for robots because most people ignored robots' admonishment. Let me show two examples. Left side, it is the case with smoking people. In this location, it is prohibited to smoke, but people sometimes still do such smoking. And if robot approach to a person who is walking with smoking, what happened? ignored. Another case, right side, this is walking smartphone behavior. Yeah, I mean, often people walk with looking at smartphone, and this is little bit dangerous. Of course, not too much, but I mean, it often very frequently, so we choose this as research target. And she's one of the person who is doing such walking smartphone behavior, and the robot approached. She just escaped, avoided, and continue doing or he using this smartphone. Yeah, this kind of ignorance frequently happened. For the problem, I mean, we decided to also model human behavior. So we found human guard change their behavior in case they do admonishment. Left side is the case with just, I mean, friendly talking. So I mean, when human guard approach and talk, just this human guard approach straightforwardly. Right side is the case with admonishment. So when human guard provide admonishment, his walking behavior is a little bit different. Velocity is relatively fast, and there is a turning point. After that, he change his moving course. So we replicated such an admonishment approaching behavior. This is the case with the robot. So robot move towards the target, and I mean suddenly turn, and I mean keep staying nearby the target. And we conducted field experiment about such admonishment behavior. And I mean, yeah, we more frequently observed people stopped using smartphone. Without having such, I mean, admonishment model, only 18% of the people stopped. But with this admonishment approaching case, 62% of the people stopped admonishment, stopped using smartphone. Still, we are continuing studying, but I mean, we believe that there is a promising future. We can foresee that more and more social robots will be deployed in our daily life, including such cloud settings. And for that, we believe that appropriate social and moral interaction is necessary for nice deployment. Thank you for your attention.
Thank you, Professor Kanda. It was a very interesting talk. You have a lot of interesting experiments. It seems quite good that abuse scenarios with the robots. Quite amazing to see that in Japan, of course. We have one first question from Professor Shatia. In the abuse scenario, it was a Wizard of Oz, or for example, is the robot's speech remotely reproduced by a human?
Yeah, I mean, in our study, I mean, basic motion was autonomous, but after that, we did some wizard watching. So I mean, when robot motion course is blocked, it automatically detects the situation. And I mean, when its motion course is not blocked yet, now it says thank you. So this simple interaction was from autonomous behavior. But I mean, sometimes we tried. I mean, actually, some video are from our trial. So robot said, I mean, don't hit me, for example. It's of course from human operator.
Okay, that's very interesting. So I have one question, and I was wondering if in all the scenarios you show, it was only children abusing the robot. Did you ever witness in any of your recordings not the children and adults, elderly adults, for example?
I mean, apparently children are more and more likely to do such behavior. And I guess maybe because they have extra time there, and also because maybe they didn't feel, I mean, they are observed by other people and adults. I mean, it's shopping mall, so they know, I mean, their behavior was looked by other people. So, I mean, there is a difference, but still we observed a couple of young adults conducted, I mean, bad behavior, like, I mean, trying to imitate kicking the robot. But it's not that frequent because they know other people are looking. But I mean, in the future, if we think about the future situation, maybe there will be robots serving in the location without being observed by other adults. Then we believe that there will be more and more risk.
Yes, of course, that's more likely, yeah. Thank you. We have one more question. Could people have fear that the robot was watching them and have stopped because of the fear to be reported? Yeah, exactly what you was just replying, right? Because they are being feared to be watched, then it's more likely that the adults do not perform this kind of abusive behavior.
Yeah.
what you mentioned. And we have one more question for you from HQNG. Oh, I'm sorry. It says, could you please explain more about the pedestrian model? Is it only based on social forces, or you have some learning model?
Yeah, I mean, it's basically social force, but I mean, it's not like straightforward social force. Let me explain a little bit more. So it's about this. So, I mean, normal social force-based model is only kind of repulsive force. So from that specific moment, there is some kind of, I mean, virtual force applied to the model. But I mean, in this specific pedestrian model, we compute future situation. For example, in this illustration, each agent think about the future in which it will be most closest with other pedestrian. And from this specific future moment, social force is applied. That's why it can predict future situation and yield the course, thinking about what would happen in the future. And I mean, of course, parameters were calibrated from real data. So in that sense, there is some sense of learning, but I think it's not what this person asked about learning aspect.
So we have one more question, and it says, does the robot navigate using predictive dynamics of the pedestrians?
Yeah, I mean, in this, for example, in this case, robot compute its future trajectories based on computed social force. So yeah, pedestrian model is used in such a way. And actually, we found we needed to adjust our pedestrian model a little bit because, I mean, pedestrian model's social force is basically for human. But I mean, in case of human robot, I mean, if we just use the social force applied for human interaction, robot approach people too much. So we needed to, I mean, because people expect more distance with this specific robot. So we calibrated parameter a little bit.
I see. Okay, we have 2 more questions. What about the GDPR issues for these experiments?
GDPR, I mean,
mostly related to recordings and the data protection. What kind of data protection are you required in these experiments?
So in our case, I mean, first of all, we got approval from these shopping mall administrators. And I mean, it's a facility under their control. So I mean, we got approval from them. And we also put some signboard and so that people can understand it is under recording.
Okay. I see. Oh, more questions coming. Do you use a physical model for prediction, but not learning model? Is that correct about the social distancing modeling?
Physical distance? Would you repeat the question again?
So I guess the question is related to the previous one, into how were you using the predictive dynamics of the pedestrians to navigate. So what the person is asking is this is only a physical prediction model of how the people behave, but it's not a learned model from data or is it?
So, I mean, physical, I'm still not very sure, but I mean, let me try to explain. So, yeah, I mean, this specific model is initially, I mean, developed with human data. So in that sense, I mean, model is, I mean, let's say, we learned from human data, but it's not like direct learning. It's not like, it's more like parametric model, and I mean mathematical description, but with parameter calibrated with the data.
Okay. I think it might be now understood. We'll keep with the next question, and is, did the robot ever hit someone involuntarily, like during raising an arm or navigating?
You mean accident in our case?
Yes.
I mean, As far as let's say, we know there is no accident like that. But of course, during developing the robot sometime because of, not fully prepared function, robot collide into wall, kind of things happened.
Okay, but not in life during the experiments.
During experiment, but of course, this is research, and we are also there, and if there is any really unexpected things, we stopped. So it's maybe a little bit different from real use.
Okay, thank you. We have one more question. A pedestrian recognition model, the person in wheelchair, a person pushing with a stroller, could be useful to better predict their behavior?
Yeah, I think, maybe it's about tracking work or maybe some prediction, based on this. Yeah, we didn't work on wheelchair kind of things. So maybe, yeah, in that sense, our model is basically for typical people. But yeah, I think it's important things we need to think about. And potential extension, because this is using a depth sensor. So we didn't do it yet, but potentially we could develop a model for, tracking wheelchair, and better predict wheelchair people, or perhaps, find, more useful paths for wheelchair, which is maybe potential future work.
Okay, I have one question related to that. In that sense, then, in your experiments, for detecting that you have children in the experiment you show trying to avoid being abused, did you have some special detector implemented for the children?
So actually, it's only height. It's depth from ceiling, and we know human shape. So it's more like either it's high or short.
Okay, so basically, the robot will do this behavior for any short person and will try to.
In that sense, yeah.
Okay, thank you very much. There is one last question, I think. Is there any vision-based sensing or learning used in these experiments?
We didn't work much for vision. If depth sensing is not considered within vision in that sense, because for this kind of shopping mall environment, sometimes people concern about using computer vision. So we more specifically focus on depth sensing, but it's our choice. So yeah, just because of that, we didn't work on vision.
Okay. So I think. So I think this is our time to conclude this talk. Thank you very much for your time, and it was a very interesting topic.